Uh, Good morning, online students. I'm audible. Could you able to hear
Yes,
me?
sir. Yes, sir.
Morning. Yeah. Okay. So very good morning, both offline and online students. So we'll start the session now. Uh, Today we will be starting with digital system design, advanced digital system design. Let me brief out like last 1 week we were started working on basically, when you are working with any editor, I mean, especially GVM editor, like how you can improve the productivity of your work, how effectively you can use the editors to manipulating the various text editing process. So that we understood. So after that, we understood about what is the role of the Linux, how to work with the Linux commands, various Linux commands we were discussing in the last 1 week, right? Probably last 1 week. So we are working on this, and today, from today onwards, probably hardly, I think it will take to cover the advanced digital system part. It will take 15 days, maximum 1 week or 2 week is required to cover the topics of advanced digital system design. So let me just put it what we are covering the advanced digital system, advanced digital system. So we'll be covering with uh, anyway why digital systems. What is the use of the digital systems? What are the places where you can use the digital systems, means digital circuits? We will talk about that. And if I talk about what we are going to cover here is, so we will be covering with the number systems, number system, and after that covering with the complements. Why need a complements? Complements. Okay, one's complement, two's complement. There is a signed representation for positive number and negative number. So what is the limitation of the signed numbers? Why especially we go complements? How complements are help to do performing the subtraction operation? What is the role of the complements? So we'll talk about the complements. So after that, we'll talk about Boolean algebra. Right? You may heard about many algebra, right? Like linear algebra. In school days, you discuss about basic algebra, correct? And here, uh, to design any digital system design where you should have idea about what algebra, Boolean algebra, how to represent Boolean equations, how we can develop the circuit, digital circuit using a Boolean algebra. So we'll talk about Boolean algebra, what Boolean algebra says, and what are the properties of Boolean algebra, how you can use this property to build the digital circuits. So we will cover that Boolean algebra. So after covering the Boolean algebra, then we will start developing logic circuits. So basically, logic circuits are two types. Those are combinatorial, means combination logic circuit, and sequential logic circuits. So we'll understand how to design the combination logic circuits. Combinational logic circuits. Logic circuit. So in the combination logic circuit, we'll understand how to design the MSI circuits. What is MSI stands for? Medium scale integrated circuits. Right? Hardly MSI circuit takes gates count from what to what? 10 to 100 gates. Correct. You know about a small scale integrated circuit, medium scale integrated circuit, correct? Then large scale integrated circuit, then VLSI, very large scale integrated circuit. You are putting millions of transistor, right? MSI means you'll be using gates count around like 20s, 30, 40, 50 gates count you're used to build a medium scale integrated circuits. Like what are the medium scale integrated circuits? Like multiplexers, like demultiplexers, Then arithmetic circuits like orders, how to build a parallel order, some advanced order like carry look ahead order, carry save order, okay, carry skip order, many more order circuits are there. So those are arithmetic circuits like orders, subtractors. You can perform the multiplication by using what? Addition. Successive addition is nothing but what? Multiplication. Okay. So how to build the arithmetic circuits, that comes in the MSI circuits. And what other medium scale integrated circuits are? Encoders, decoders. So those are like bit compressors, bit expanders, we can call. So those are encoders and decoders. Counters is not comes in the combinational logic circuit, that comes in the sequential logic circuit. And you may heard about comparators. Comparing of the bits, 1-bit comparison, 2-bit comparison, or multi-bit comparison. Okay. So all these circuits comes under in our combinational logic circuit. So after this, we'll be dealing with sequential. Very important circuits are what? Sequential logic circuits. Sequential logic circuits. In sequential logic circuit, we'll discuss about first initially latches. How to build a single storage element, single bit storage element. So once you understand how to build a single storage element, so that you can build a multi-storage element. Okay. So what is a latch? What is the use of the latch? Then what is a flip-flop? Types of flip-flops. Okay. How to build a flip-flop? So using flip-flop, how to build a what? Counters. Like a synchronous counter, asynchronous counter, correct? Like some register-based counters. Those are like Johnson counter, we can call ring counter, you can call. We call that is special counters. Okay. So we'll talk about various counters like register-based counters, synchronous counters, asynchronous counter. We'll see what is the limitations of synchronous or asynchronous. Okay. We'll see how to develop the counters, synchronous and asynchronous counters. So then we'll also understand how to build the registers. How to build the registers like grouping together D flip-flop, we usually call it as a register. If you have data in the register, you can do various configurations. You can put the data in serial way and get the serial output. Put the data in serial input, parallel output. These are configuration. Usually we call CISO, CIPO, PIPO, PISO. And then you want everything you want need in a single circuit that we call universal shift registers. Okay. We'll understand how to build the registers, and then also we'll understand how to build the counters based on the registers, like special counter. Someone is mentioned, like what is a ring counter, what is a Johnson counter, what are the applications of this special counters. And after building of this, we'll go for building of FSMs, finite state machines. So like Millet models, Moray models. So what is the use of these Millet models, Moray models? So we'll understand the building of FSM. So first, we'll understand what are the digital systems, where you can see the digital systems. Where you see the digital systems? Nowadays, everyone is carrying the digital system. Everyone having mobile. Mobile, if you break your mobile, see inside. You see the chip. The chip is built using what? Digital systems. All your CPU, your integrated chip will build by using digital circuits like gates, number of gates. Gates means even if you break the gate, see inside the gate what is there? Like components, devices you can call. What devices are there? If you break the gate and see inside, like active devices and passive devices. Active devices means your transistors. Passive devices means resistors, capacitors. You understood? There is no place nowadays, correct? Almost all the places we are using what? Digital systems. If you talk about your computer, if you talk about your mobile phone, if you talk about your digital clock, if you talk about your digital measuring instrument, automobile industry, all the places. So you can see the what? Digital system design. Correct. Of course, analog should be there. All the real-time signals, whatever speech I'm talking about, is in analog in nature. So nowadays, people are trying to push as much of analog signals is trying to push into the what? Digital. Why? Because of digital having more reliability, less immunity to the noises, cost effective, correct? Less power, less area. So these are what use advantages of the digital. Uh, Nowadays, people are trying as much as possible. All the analog signals are trying to push into the what? Digital. Means digital manipulation is easy. Processing of data is easy because you will be having only two distinct values. Those are what? Ones and zeros. And one very important use of the digital system is nothing but you can design the high precise device by replicating. Replication is allowed to maintain the accuracy of your system. In digital, replication is allowed. Okay, but accuracy is directly proportional in the digital by going with the what? Higher, I mean replication. It is not same true in the analog. If you want to maintain the accuracy, you have to put a lot of effort. Means your circuit is a bulky circuit you have to design. Means size of your device will be what? Bulky. It's not so easy if you put a effort to meet the accuracy of analog, so that people are trying to move all the analog signals into digital. Correct. So if I talk about the block diagram representation of the system, so we have a digital system. We have a digital system, correct? So all the naturally occurring signals, real-time signals are in what nature? They are in analog nature, correct? Analog input, get the analog input, correct? To put into the what? To put into analog to digital converter. Convert the analog into digital, then put into what? Digital system. Digital system. Do process. So the main use of the digital system is nothing but the storing of huge data. Storing and transmission. If you look at the computer, computer is not only using for one operation, right? It is not using for only computing. If you talk about banking applications, so they'll be using computer for what? Storing of the data. Some applications, specific applications, computer used to do some computations, some performance. I mean, some operations it has to do. In some application, your system means computer should work for what? Storing of the data. Means in a digital, storing and transmission is easy compared to what? Your analog signal. So that we'll convert all the analog input to the into what? Digital. Because of what is the advantage of the digital? Because of reliability. Because of the high reliability. Because of what? Cost effective. Because of what? Size. Because of size. Because of what? Power consumption. Less power consumption. Less power consumption. So convert all the analog into digital. Do various process means transmission of digital, storing of the digital. Okay. So again, convert this into what? Digital to analog converter, and then this is what your analog output. Analog output. So at the end to end, if you see the interface, it will be analog. Without analog, there is no digital actually, correct? But analog to process, correct? To processing of the signal, correct? Storing of the signal, transmission of the signal is not much good than what? Your digital. So that push all the analog signal, try to push into the digital. So because of this advantages like high reliability, high cost effective. The design of digital system is easy because it allows you for what? Replication. Okay, higher order you can design using lower order by replication. This is what one good use of the digital. Okay, so that cost effective because of size and because of what? Power consumption. If you talk about what are the digital systems, sir, what are the digital systems? What are the digital systems? Can you name some examples of the digital systems? Computer, you can call it as a what? Digital system, right? Smart watches. Smart watches, correct? Digital measuring unit. You see your bike, suppose you are buying a new bike nowadays, right? Your speedometer. Earlier it was in analog, way back to 20, 30 years back, it was an analog, correct? So speed is measured, is in analog nature. Now that is replaced by what? Digital, correct? So digital measuring instruments, there are many use of what? I mean, many examples of digital systems. Now, in this course, we'll understand what is the property of a digital system. Okay, how to analyze the digital system, how to build the digital system. So we should understand analyzation of digital system, building of the digital system. What is the property of the digital system? That is what we are covering in this. Okay, I'm not talking about how to build, how to convert analog to digital and digital to analog, because this is an interface. End-to-end interface will be analog, but we should know that how to build the systems. So basically, like computer is a system, digital watch is a system, correct? Examples, and digital measuring instrument are the systems. These are the systems, correct? How to build a system? If you take a computer, what computer consists of? What digital component it is consists of? CPU, correct? If I talk about computer consists of what? Systems like what? Central processing unit. Then what? Memory. Correct? Then what? There are input-output interfaces, etc. devices. Correct? So this I can call it as a what? Systems. This we call it as a systems. How we can build a CPU? How to build the systems? How to build the systems? I mean, CPU, central processing unit. What central processing unit consists of? What central processing unit is consists of? The CPU consists of what? How to build the CPU is nothing but what? ALU, right? ALU is required to design the memory. You need a what? The registers. So this is, we call it as subsystems. This we call it as what? Subsystems. Systems are like what? CPU, memory, input, output, other some digital components. We call it as systems. To build the CPU, what do you need to build? You need to build the arithmetic logic unit. Arithmetic logic unit consists of what? Circuits. What circuits? Adder circuits, multiplier circuits, subtractor circuits. It may be division, it may be exponential, some arithmetic operations. Also, it performs the what? Logical operations. Logical are various logical operations. Correct. So to build the system, what do we need? What do we need? Suppose I want to build a CPU, what I need? I need a ALU, arithmetic logic unit. This is nothing but what? Subsystem. How we can build a subsystem? How we can build a subsystem? How we can build a ALU? Arithmetic circuits, correct? Arithmetic circuits like adders, subtractors, etc. Some logical circuits. So that we call it as what? Modules. That we call it as a modules. So modules are designed by using functional blocks. Functional blocks. Functional blocks are designed by using what? Functional blocks are designed by using what? Logic units. Logic units. Logic units are designed by what? How to build the logic circuits? Let's how to build the gates using transistors. I can call that is nothing but what? Devices. Devices means what devices? It may be passive devices or active devices. Passive devices and what? Active devices. Or you can call components, passive component or passive component and or active component. So what are the passive components are like? Resistors, capacitors, inductors, etc. Correct? What are the active components like? Transistors. Correct? Transistor means what technology node you want to build a CPU, right? Whether you want to build using 5 nanometer or a 7 nanometer or 3 nanometer, 1.4 micron means 1.4 nanometer. Okay. So what nanometer you want to build a circuit? Correct? So to build a system, basically what you need? You need an active and passive component. Using this active and passive components, you can build the devices like logic units. These are the devices. Using these devices, you will build the what? Gates. Gates are used to build the what? Functional blocks. Functional blocks are used to build the what? Modules. Modules are used to build the what? Subsystems. Subsystems are used to build the what? Systems. Are you understood? So here devices means like capacitors, resistors, inductors, etc. Transistor, active devices. Logic unit means what?
Gates.
Gates. What gates are?
Functional.
Functional gates. You call basic gates, correct? You call what? Universal gates. You call it as what? Applications gates. All these we call functional gates. We call, in terms of VLSI vocabulary, we won't call gates. In digital vocabulary, we call it as a gates. When it is coming to the VLSI vocabulary, so we call standard cells. We call standard cells. So cells again, different types are there. The cells are like standard cells. Cells are like physical cells. Cells are like power cells. Cells are like clock gating cells. Many cells are there that eventually will deal when you move to the advanced part. Like functional cells are used to functionality of the design. Physical cells are used to avoid the fab related defects. Like various defects are there. Well proximity problem. Okay. There is a problem called latch-up problem. To maintain the continuity of N-well, we'll be using filler cells. To improve the gate IR drop, to improve the power of the cell, we'll be using a cell called decap cells, antenna cells. So those we call physical cells. And some cells are there, like retention cells, isolation cells, always on cells. Those are relating to the what? Power controlling. And few cells are using for clock controlling. Clock gating cells are there. Like cells are broadly classified into different classes. But as in a digital system, so we'll talk about what? These functional cells, whatever the gates I'm rating, basic gates like AND, OR, inverter, correct? Universal gates like NAND and NOR. Applications gates are like XOR and XNOR. Like it is used to check the even parity and odd parity checker. You can use the applications gates like XOR and XNOR. So these cells are used to build the what? Functionality. Like to build the combinational circuit, to build the what? Sequential circuit. So these we call standard cells when it is coming to VLSI vocabulary. So logic units are like what? Gates. So using these logic units, you are building the what? Functional blocks. Functional blocks means like what? Like suppose I'm building a what? Using the full ladder, I'm building the parallel ladder. That is a one functional block. Parallel ladder is a one functional block. Using a functional block, parallel ladder, I can build a what? One module. Using this module, I can build a what? Subsystem. Like ALU, registers, etc. I can build. Using this subsystem, I can build a what? System. This is what hierarchical approach. To build a system, you have to build a subsystem. Subsystem is built using modules. Modules are you building functional blocks. Functional blocks are building logic gates. Logic gates are building using gates, I mean devices, components. Okay. This is what the top-down approach. To build a system, you have to go like hierarchy. This is what the top to bottom approach. So in this course, so we are not dealing with how to build the CPU. We are not dealing with how to design the what system. This course, digital system design course, will not going to build the systems. We're not going to build the subsystems. We're not going to build the modules. So we'll be understanding using logic gates. What are the logic gates? Using logic gates, how you can build the functional blocks. Functional blocks like I said one example, orders. How to build the orders, how to build the counters, how to build the registers. So using this, you can build the modules. Modules are used to build the subsystem. Subsystems are used to build the systems. So to understand, to design the system, what idea basically you need? Suppose I want to design a system like CPU. If you look at the hierarchy, from where you need to start? You need to start from, you need to understand how to build the ALU, how to build the modules, how to build the functional blocks, how to build the logic units. So in this course, mainly we'll focus on what? Logic gates. Using logic gates, how you can build the functional blocks. Correct. Again, this is another course where you should understand what is a transistor, how transistors like NMOS and PMOS are used to build the CMOS, how you can use the CMOS to build the AND gate, how CMOS can be used to build the OR gate, other gates. But I'm not going through much detail about this device level details. But in this course, we'll go with the what? Logic units. How you can build the logic units. Using logic units, how you can build the, at least we'll understand how to build the functional blocks. Then once you know that how to build the functional blocks, then you can extend your knowledge to build the modules and subsystems. Then what? Systems. Are you understood? So our main focus is to build the what? Logic gates using Boolean algebra. So Boolean algebra, use the knowledge of Boolean algebra, then you understand how to develop the combinational circuits. Like multiplexers, demultiplexers, encoders, decoders, comparators, some arithmetic circuits. Then you can build the functional blocks. So these are our hierarchy to design any digital system. So digital system will be used in many applications, right? Many applications. So this is what the hierarchy, this is what the approach to build the digital system. Are you understood? So this is what we call top-down approach. Top is system, bottom is what? Your devices, passive and active components. Are you understood? So to understand, to develop the logic units, to develop the functional blocks, first you should have foundation about Boolean algebra. To understand the Boolean algebra, first you should have idea about what? Idea about number systems. So we'll start from the number systems first. So now what is a number system? Why do we need a number system? What are the types of the number systems we have? Usually you know that there is a binary number system widely used in what? Where you use a binary? Your CPU. CPU will understand zeros and ones. Because that you build using the logic gates. Logic gates means what? Gates means if you break the gate and see inside there is a transistor. What is the use of the transistor over there? Switching. Turn on, turn off. By switching, you can perform the logic operation. Using logic operation, you can perform the functionality. I mean, you can build the various combinatorial and sequential circuit. Using that, you can build the other modules, subsystem, like systems you can build. Correct. So widely, you know how to what are the number systems. The number system means daily usage will be using a number system called what? Decimal number system. And second type of number system is what? Binary number system. All your digital circuits will understand what? Only two distinct values. Those are zeros and ones. The other number system is what? Octal number system. Octal number system. Other number system is what? Hexadecimal number system. So why do we need an octal number system and hexadecimal system? To represent the bits, means binary bits you want to represent in more compact manner. So we'll be using octal number. hexadecimal number, correct? Also same, it is used to represent the binary in more compact manner. You can use the hexadecimal number, correct? Usually in microprocessors and microcontroller, the address of the memory, correct? So will be represented not in binary, it is represented in hexadecimal number system. Means more compact form of your binary you want to represent, you can go for what? Hexadecimal number system. What other number system you know apart from this? This what as a student, correct? As an engineer, you know this number system. What other number systems are there? What other number system is there? Usually you call it as a X number system. There is a what? X number system. Right. If I talk about decimal number system, what is the radix of this number system? What is the radix? 10. Radix is 10. Or this can be denoted by small d, right? And it is also denoted by what? Capital D. Or it is denoted by what? Like suppose if I'm example, if I'm representing a decimal number system, usually when you write a number for daily usages, right? General usages, the number you simply write like this, right? Simply write like this. But you are not representing with the what? Base of this number. But you are assuming that this is what number? By default, it is a decimal number system. Daily usage, you'll be using what? Decimal number system. So if I'm representing like this, base R is nothing but base 10 means what? Decimal number system. Or you can represent what? 25 of D or 25 of capital D. Or simply if I just write 25, that means that what? It is decimal number system. So what is the purpose? What is the use of the decimal number system? Daily usages to count the amount, to count the steps, to count something. So we'll be using what? Decimal number systems. And what are the unique digits of the decimal number system? What are the digits of the decimal number system? 0 to 1, including 0, 0 to 9. 0 to 9. The unique digits of the decimal number system is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 is nothing but decimal number system. The count of these digits will give the what? Radix. Correct? That is what the radix of this decimal number system. What is the count of these digits? 0 to 9 means 10. You got base of 10. Are you understood? So if I'm able to represent based upon the number of digits, this is a base of 10. I can also represent X number system, right? I can also represent X number system. Let's say X is equal to 5. X is equal to 5. Are you understood? So what are the digits of this number system? Here X means X number system. This is X number system. Or if you are not able to understand X, I can simply write a R number system. R means what? Base, radix of the number system. If I write here radix is 10, by default you are understanding what number system it is? Decimal number system. If my radix is equal to 5, what number system it is? What number system? This is a base of what? 5. This is a base of 5. If R is radix is 5, what number system is nothing but it is a base of 5. So let us write 25. What is the base is nothing but 5. So what are the unique digits of this number system then? 0 to 4, right? 0, 1, 2, 3, and 4. What is the count of these digits? 5. What base it is nothing but? Base of 5. But usually you will be using base of 10, base of 2, base of 8, and base of 16. But also you can represent number system with any base. Are you understood? So how to calculate the radix of this binary number, decimal number system? How to calculate the base of this number system? Is it divided by? No, I want to find out what is the radix. It's a base. I can use the formula radix is nothing but, or base is nothing but, radix or base both are same. Radix or base is equal to what? 0 to r minus 1. What is r is? Radix. 10. 10 minus 1 is what? 9. 0 to 9 is nothing but base of 10. To find out the base of any system, base of any number, suppose I want to find out what is the base of this, I can write what? Radix or a base. Radix of this is nothing but what? 0 to r minus 1. What is r is? 5. What is 5 minus 1 is? 4. 5 minus 1 is 4. 0 to 4 means how many digits? How many unique digits? 0, 1, 2, 3, 4. So that I can simply call X number system. X may be, radix may be 7. Radix may be 8. Radix may be 9. Radix may be 10. Radix may be 11. Any number system. You don't understood? But commonly we'll use 10, base of 10, base of 2, base of 8, and base of 16. This is what common number system, but number system also you can represent as what? X number system. For X number system, if you want to find out the radix or a base of that number system, what is the formula you can use? You can use 0 to r minus 1. Now I'll ask a question. What is the range of the radix? 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 Huh? The range of the radix or radix, always it should be greater than or equal to 2. 2. And actually there is no upper limit. You can represent any digit, any finite digit. That is what the radix. But usually the radix range you can take from r is greater than or equal to 2 to 64. I mean radix of 2, radix of 3, radix of 4. But the maximum range you can take radix of 1, 64. If radix of 64 means how many unique digit of that radix number? 0 to 64 minus 1, 0 to 63. But there is no upper limit. But most of the common computers, what we have, it will take a range up to what? 64. This is what the range. So range of the radix always should start from the what? You see any one number system? No, right? There is no one number system. So radix at least start from the where? 2. It may be 3, it may be 4, it may be upper limit, some upper limit. And what other property of the, this is what the range of the radix. Radix should be always a what? You see any radix number with the negative radix number? All right. Whole number, always, correct? Radix should be what? This is what the range of the radix. Range of the radix. Radix should be what? Should be always a what? Whole number. Whole number. Radix should be always a whole number. Do you agree? Do you see any number system with the base of -1? Base of integer. It is, even it is not an integer. Radix is not an integer. It is a what? Whole number. Radix is a whole number. So what I'm trying to say is nothing but, if x is equal to 10, what number system it is? Or r is equal to 10, what number system it is? Decimal number system. R is equal to 2, binary. R is equal to 8. R is equal to 16, hexadecimal. If R is equal to 7, it is a base of 7 number system. It is a base of 7 number system. So that I can represent number system, I can represent as what? X number system. Are you understood? Now let us come into the next number system is what? What is the radix of this number system? is nothing but a 2, right? You can write a B or you can write what? Capital B. So what is the example of this is nothing but, let me write 0010. Base you can write what? 2. Or you can write as a D, sorry, B. Or you can write as a what? Capital B. So what is the radix of this octal number system? Okay, what are the digits for this? The digits of binary is nothing but 0 and 1. Digits are 0 and 1. If I talk about octal number system, what is the radix is? 8. How to represent octal number system? Example, you can write some number with the what? Is this is correct way to represent? Suppose I am writing like this. Is it octal number? No, why? The digits will appear what? The unique digit which should appear between what? 0 to 7. 0 to 7. So this is a wrong way to represent the what? Octal number. So octal number unique digits are what? 0 to 7. So example, if I'm writing 17 base of 8, this is octal number. Or you can write what? Small o. Or you can write what? Capital O. So what are the digits of this? What are the digits? The digits for this is 0, 1, 2, 3, 4, 5, 6, 7, and 7, right? 7. After 7? After 7, if I want to extend my octal digits, 1, 0, 1, 1, 1, 2, 1, 3, like so on. So after 9 in decimal, what is the next number is? 1, 0, right? 1, 0. Then 1, 1. Then 1, 2. Again 1, 3. Up to so on what? 1, 9. Again you start from what? 2, 0, 2, 1, like so on. Auto understood? The other number system is nothing but what? Hexadecimal number system. Hexadecimal number system. What is the radix of this? Radix is 16. You can write a small h or you can write a capital H. What is the example is? If I write A, B, C, D, right? A means what? 10. B means 11. C means 12, 13. So the base of what? 16. What are the digits of this? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After 9, A, B, C, D, E, and F. After F, 1, 0. Again 1, 1. 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1, 8, 1, 9. Then 1 A, 1 B, 1 C, 1 D, 1 E, 1 F. Then 2, 0. If it is a R number system or X number system, you know how to write the unique digits of the R number system? R minus 1, right? 0 to R minus 1. Are you understood? This is how you can represent the number systems. In general, you can say X number system. If X is 10 by decimal, X is 2 binary, X is 8 octal, X is 16 hexadecimal. Okay. If X is 7, it is a base of 7 number system. Are you understood? Now let us talk about conversions. Conversion means what? Suppose I have a decimal number system, I need to convert into binary, I need to convert it into octal, I need to convert into what? Hexadecimal. Is that is possible that my decimal number system I can convert it into other number system base of 5? Yes, correct. You can convert binary, you can convert octal, you can convert into hexadecimal. Also, you can convert it into what? Any other X number system. So now let us discuss about conversions. Let us discuss about conversions. That first conversion is what? Let's say, decimal to binary. What other conversion you can do? Decimal to octal, decimal to hexadecimal, or decimal to some X number system I can call. Some X number system. Correct? So what is the logic? How you can convert decimal to binary? The number means, suppose if my number is like 16 in the decimal D, I want to convert this into the what? Binary. I want to convert this into binary. What I have to do? Actually, if you look at the decimal number, my decimal number is, I can represent like this. What is this dot is? Decimal point. So this number I am representing like this, right? So this part of digit, what you call? What you call this part of digit is? Integer part. This part you can call it as what? Fractional part. Correct? This is the integer part and this is a fractional part. Let's say I want to convert my decimal number into the what? Binary number. What I have to do? Take the integer part. Take the integer part. Take it integer part. What is the integer part is? 16. Divide this number by what? By whatever it is number system. If it is a binary, divide by binary. If it is octal, divide by 8. If it is hexadecimal, divide by 16. If it is X number system, divide by X number system. So how many times I can divide? 8 times. What is the remainder is? 0. Correct? How many times I can divide 4? Sorry, 8? 4 times. What is my remainder is? 0. How many times? 2 times. What is my remainder is? How many times 2? 1 time. My remainder is what? 0. So 1 time I can divide. What is the remainder I am getting? 0, right? 2 ones are right. Is it correct? So then what I should do? Take the result from what to what? Bottom to the what? Top. Take the result from bottom to the top. So 16 in the decimal, what is the equivalent in binary is 1 0 0 0 0 with the base of what? 2. 3 zeros or 4 zeros it is. 3 zeros means it is 8, right? Huh? 4 zeros, right? 16. See how many times I can divide? 8 times, right? The remainder I am getting 0. Here 8 is how many times I can divide? 4 times. Again 4 is divided by 2 times. 2 is divided by 1 time. Take the result from all this remainder I will get 0. Are you understood? Now take the result, all the remainders from what to what? Bottom to the top. When it is a what? Integer part. Integer part. If it is a fractional part, successively multiplied by 2. Take all the remainders from what to what? Top to bottom. Top to bottom. Can you take one example and convert? Correct? So the example is, you can take the decimal number 15.50 with the decimal. This you can convert into binary. What are the steps are? Take the integer part. Successively divide by what? 2. How many times? 7 times. What is the remainder is? 1. Again, how many times? 3 times. What is the remainder is? Again, how many times? 1 time. What is the remainder is? 1. Take the result from what to what? Bottom to the top. So this is 15 means what? 1, 1, 1, 1. You understood? Dot. Fractional part, what I have to do? 0.50 successively multiplied by 2. How many times? 1 times. So 0.5 into 2 means what? 1.00. What do you have to do? Take the result out. Right? Take the result out. So then it should be what? 0.00. If you multiply this, you'll get what? 0.00. You take 0 out. Means 0.50 in binary is what? 10. You understood? The base of what? 2. The base of 2. Are you understood? So until actually this 2 is 0 is not there, right? Because I'm getting, if I'm taking 1 out, 0.00 divided by multiplied by 2 means what? 0, 1. So I can write what? 1. Correct? You don't understand. 1 or 0 I should write here. 1, right? This is nothing but 1. Are you understood? So there are some fractional part where you have to continue some 4 or 5 digits. It's keep going on. Then you should limit yourself to stop at 4 digits or 5 digits. Are you understood? Now you can do exercise on how to convert the decimal to octal, decimal to hexadecimal, or a decimal to any number system. Can I give one question to be able to solve it? Huh? So my question is, okay, before going to that, I'll just give a few more examples. You take some examples like, suppose this was my number. Let's take this was my number, decimal. This you should convert it into binary. This you should also convert it into octal. This also you should convert it into hexadecimal. Hexadecimal. You know how to do, right? So I'm giving only integer part here. I have not given the fractional part. So integer part will be successfully divided by what? 2. How many times? 32 times. What is the remainder is? 0. Again, how many times? 16 times. Remainder is 0. Again, how many times? 8 times. Remainder is 0. Again, how many times? 4 times. Remainder is 0. Again, how many times? 2 times. Remainder is 0. Again, how many times? 1 time. Remainder is 0. So what is the result is? In binary, it is 1 followed by how many zeros? 6 zeros. Then how to convert this into the octal? Octal means the number is divided by what? 8. How many times? 8 times. What is the remainder is?
0.
Again, how many times? 1 time. What is the remainder is? 0. Result will be top to bottom. Sorry, bottom to top. So octal number is nothing but 100 with the base of 8. What is the hexadecimal number? 16. Right here, this octal. 64 divided by 16. How many times?
4 times.
4 times. Remainder is 0. What is the result is? 40 with the base of what? 16. Are you understood? So I'll guess, okay. For this conversion from the decimal to other number system, so I'll give some examples now. So can you tell me what is the answer to this question? So whatever I have covered right now, can you see the question of this one? It's not copying. Okay. What is the question is 2 1 of A, 2 1 base of what? X. Find all the possible values of X. My question is 2 1 A of X. What is my question? First question is find all the possible values of the what? Values of the X. Second, the second question is find the minimal values of the X. The second question is find the minimal value. Find the minimal values of the X. Can anyone solve this problem? What is my number is? 21A, right? My number is 21A with the base of what? X. What is the X is here? Radix. What the radix value it is? Is it octal? Probably it may hexadecimal. So my question is find all the possible values of the X I am talking about. All the possible values of the X I am talking about. What is my X value is? 0 to? Is it 0 to 15? No. 0 to 9. What is the base of this number? Is it base of this number is 11? How many of you are agree? So my question is the possible values of X is greater than or equal to 11, greater than or equal to 12, greater than or equal to 13, like so on. These are the possible values of the X. How? Look at this number 21A. What is the maximum digit is? A. What is the equivalent value? Is 10. If it is a 10, what is X is? It's supposed to be 11. The base of 11, what are its digits are? If X is equal to 11, correct? What are its digits are? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Here A means what? 10. It is 10 actually. Then what is the base of this number is? 11. All the possible values means X may be 11. It should be greater than or equal to 11. It may be what? 12. It may be 13 or like so on. Some finite value. Are you understood? This is the answer to the what? First question. Finding all the possible values of the X. Then what is my second question is? What is the second question is? Find the minimal values of the X. What are the minimal values of the X is? 11. The minimal values of value of X is what? 11. Are you understood? If I give some number with some X, X, you know how to identify the base of that number system? Are you understood? Okay. So let me give one more example. Let me give some typical examples now. So let me give another example is. Okay, can you solve this number? What is my number is? Let us take find the value of X. The next question is find the value of X. I'm talking about finding the base of the numbers. Base of the numbers. My question is 135 of base of X. 135 base of x plus 144. Okay. Base of octal it is. Okay. Base of 8. Then this is equal to 214 of x. This is equal to 214 of x plus 2. Plus 2 means different number systems are what here, what we have done here. Summing. This is a x number system. This is also x number system. This is what number system? Octal number system. By default to 2 means what? It is decimal number system. So what I need to do here? I need to find the value of x. How to find the value of x? In previous case, damn easy you to find out the value of x here. But there is no LHS, only the number with the base x. Right? Now you can easily identify what is the possible values of the x, what is the minimal values of the value of the x. Let's say if I give like this. This is what? Some number. That some number what? Odd. Is saying that LHS is equal to what? RHS. You should choose the x value such that LHS should be equal to the what? RHS. Then how to solve this problem? What knowledge is required to solve this problem? What knowledge is required to solve this problem? How you can solve? What is the approach? What is the approach to solve this problem? X plus x plus 8. Why x plus 8? The approach for this question is converting all the numbers into what? Decimal number. Converting all the number into decimal number. How to convert octal to decimal? How to convert octal to decimal? This is what my octal. What is my number is 144, right? 144 with the base of 8. How to convert this into the decimal? Then we should go for weighted power, because that is nothing but what? Weighted power. All the weighted powers are what? Sum together. So this is number. I can write 144.00 something, some digit, means 0 digit only it is. What is this point is nothing but octal point. This is octal point. So octal point, what is the power of this? Weighted power of this? This one is nothing but what? The weighted power is 8 power 0. What is this is nothing but 8 power 1. What is the weighted power of this? Nothing but 8 power 2. What I have to do? All this weighted power should be what? Multiplied with the digits. Then we need to what? Sum up. So to convert the octal to the decimal, what I have to do? So each digit will be multiplied by their weighted power. So what is the weighted power of 1 is? 8 square. Plus what is the weighted power of 4 is? 8 power 1. What is the weighted power of what? Again 4 is what? 8 power 0. What about the fractional part? Weighted power should be divided. Here it is multiplied. Here what you should do? Weighted power will be what? Divided. So 0 into 8 power minus 1, you can call what? 0 by 8. 0 by 8 power minus 2 means what? 8 square. Means that is 16. Right. So 8 square, okay, sorry. 8 square is nothing but it is 64. Sometimes I may represent digits. Calculation may be wrong. You need to correct it. Okay, you need to correct it. So now what is 8 square is 64. Then 4 into 8 is 32. So 8 power 0 means what? 1, right? This is nothing but 4. Again, this is what? 0 only. I'll just neglect this because since it is 0. Okay. So 0 by 8 is 0 plus 0 by 64 is 0. So what is the value of this is nothing but 100. With the base of what? Decimal. So 144 in octal, that is equivalent in decimal is what? 100. So now I have converted this octal into what? Decimal. Then how to convert this number into the decimal? Weighted power only, right? Weighted power. This number into decimal means what? 1 into x square plus 3 into x plus 5 into x power 0. This is x power 1, x power 0. X power 0 means what? 1 only. You understood? Convert this into decimal. If you convert into the decimal, you'll get x squared plus 3x plus 5x plus what is this? Is nothing but 144 in decimal is 100. Similarly, what I have to do? Convert this into decimal. This is nothing but what? 2x square plus x plus x to the power of 1 plus 4 into x power 0 plus what? 2. Are you understood? Again, how I can write this is nothing but this is x square minus 2x square 3x minus x plus 5x 5 minus 4. Again, if you put this 2 left side minus 2 plus what? 100. This is equal to 0. I can write. Then if you simplify this, what is the result you will get? Minus x square plus 2x, and what about this result is? Plus 99. Plus 99 is equal to 0. I got this result. What is the result is? Shall I change the slide? I'll get minus x square plus 2x plus 99 is equal to 0. This equation you can write what? X square minus 2x minus 99 is equal to what? 0. Now I need to find out the x. So this is in the what format? Quadratic format. Quadratic equation. How to find out the values of what? X. X is equal to what is the formula to find out the quadratic equation? To the power of 2. Minus b plus or minus root of b square minus 4ac divided by what? 2a. So this is similar to what? A into what? I can write x square, correct? Plus b into what? X plus c is equal to 0. What is the a value is equal to? 1. What is the b value is equal to? Minus 2. What is c value is equal to? Minus 99. Can you find out the roots of this equation? Roots of this quadratic equation? Yes or no? What is x value? I think you will get the 2 roots, right? 2 roots you will get. What are the 2 roots are? For until digital, I recommend you to bring your calculators. I think you make your calculator sleep, right? Now you should awake your calculator. What are the 2 roots? 11. Other root is what?
Minus 9.
Minus 9.
9.
What is the correct value of x is now? 11. Why 11? Because radix should be whole number. Radix should be greater than or equal to 2. Correct? The correct root, correct value of this is nothing but x is equal to what? 11. X is equal to 11. Now put 11 in this equation. Put 11. Then convert that into what? Decimal. Can you prove LHS is equal to RHS? If you substitute x is equal to 11, this you can write 1 into 11 square plus 3 into 11 plus 5 plus what? 144 in decimal means what? 100. And this is nothing but 2 into 11 square plus 1 into 11 plus 4 plus 2. If I substitute x is equal to 11, is it LHS is equal to RHS? Can you prove it? Yes or no? Are you getting LHS is equal to RHS? RHS. If X is equal to what? If X is equal to 11. Are you getting this result? Yes or no? So the right value of X is nothing but 11. Can I give one more different question? Can you solve it? So my point is not to solve like binary to octal, binary to some other. My point is that I want to give different question to solve it, because already you know conversions, decimal to other number conversion. Just now we saw. Then in this question we understood how to convert decimal to any other number system. So you should go for what? Integer part. You should go for what? Weighted power. Multiply with each digit is multiplied with the what? Weighted power. Then you do the sum. Fractional part divided. Weighted power will be divided. Then you do the sum. These are decimal to any other number conversion. You can do it. Now let me give another question. So can you solve this question then? Find the R 136 of base 10. This is very simple question. Find the R. Find the what? R. What is the question is? 136 base of R, then 210. Huh? Base of 10 and this is base of R. 210. This is base of 10. This is base of R. This is already this number in what? Decimal only. Now this number you should convert into what? 210 base of R. You should convert into what? Decimal. How to convert this into decimal? 2R square plus what? 2R plus 0 is equal to 136. Sorry, this is 1R. This is just R. Correct. So 2R square plus R minus 136 is equal to 0. Again, this is in the quadratic equation form. Then you should find out the roots of R value. What are the R values, sir? What are the R value?
Sir, 8.
8. Right? If R value is 8, if you substitute R value is 8, you get two roots, right? One root is what? One root is 8. What is another root is?
Minus 8.5.
Minus 8.5. What is the correct value of R? Is 8, because it is a whole number. Radix should be whole number. If you substitute 8 here, convert this into decimal, then LHS should be equivalent to the what? RHS. Are you understood? Okay. So I'll give one more question here. Let's take this is a number. So can you convert this into decimal? Sorry. Can you convert this into decimal? Also convert this into what? Octal. Also convert this into hexadecimal. How to convert this number into decimal? Weighted power. Correct? Each digit of your integral part will be weighted power and do the sum. It is the fractional part, divide the weighted power and do the sum. So that you can convert it into decimal. How to convert a binary number to the octal? Let me copy the same question here. I'll just write, okay. So this I can write 1 into what? 2 power 0, 1, 2, 3, 4. 2 power 4 plus 0 into 2 power 3 plus 0 into 2 power 2 plus 1 into 2 power 1 plus 0 into 2 power 0. Correct? So 2 power 4 means what? 2 power 4, 16. 16 plus what? 16 plus 2 means what is the result is? 18. So 10010 in decimal is nothing but what? 18. Is it 18? Again, you how to convert the decimal to binary? Successfully divided by what? 2. Here you are multiplied, all the weighted power you are multiplied, you did the sum. To convert this into binary, successfully you should divide it by what? 2. Then how to convert this number into octal? 10010 base of 2. This I want to convert it into octal. Group of the binary digit into what? 3 groups. Why 3 groups? Why it is a 3 groups? Because if you see the octal number, what are the octal numbers, sir? 0, 1, 2, 3, 4, 5, 6, 7 are the octal numbers. To represent octal number, you can use a 3 digit to represent the octal numbers in binary, like 000, 001, 010, 011, 100, 101, 110, and 111. So this binary number, we should group with how many digits? Group with the 3 digits. And what is this digit then? We should consider as 0. So 010 means what? 2. Again 010 is nothing but what? 2 only. What is the equivalent octal number is nothing but what? 2 to the base of what? 8 or O. Then how to convert same number into hexadecimal?
4 digits.
Group with the what? 4 digits. Why 4 digits? Hexadecimal is 0 to 15. To represent hexadecimal 0 to 15 in binary, you need a 4 bits. So that you can group. Group with what? 4 digits. Grouping is start from the left to right or right to left? It is decimal point left to right. Sorry, right to left. From the this is what your binary point, right? From the binary point, you should do what? This is what the left to right. Left to side you should go. Binary point right side, you should go to the right. You don't understand? Now if I group this 0010 means what? 2. And what is the next digits you can consider as? 1. This you can consider this is a 1 in the base of what? 16. Base of 16. Now we understood from this example how to convert binary to decimal, binary to octal, binary to hexadecimal. If I give the number 64 or let us take 65 in octal, how to convert this into the decimal? How to convert this into binary? How to convert this number into what? Octal, hexadecimal. Octal to binary decimal means what? Divide by 8. Weighted power. Decimal to other number, integer part will be divided, fractional part will be multiplied. Correct? Other number system to decimal means you should go for weighted power. So this is 65 with the base of 8 is nothing but 6 into 8 power 1 plus 5 into 8 power 0. What is the value is? 50? 53. 53 with the base of what? D. Now same number I want to convert this into what? Binary. How to convert this into binary? Represent each digit with a binary. 6 means what? 110. 5 means what? 101 with the base of 2. So how to convert this number into hexadecimal number? First you represent this in the binary, correct? Then group with the what? 4 digits. This binary, then you know how to convert binary to what? Hexadecimal. So this I can write XX means 0011 means 3. 0101 is nothing but what? 5 in the hexadecimal number system. Correct? Is it correct? Now you can take hexadecimal number. You take the hexadecimal number, convert this into decimal, convert that into binary, convert that into octal. So let me give one hexadecimal number. My hexadecimal number is nothing but AB. AB in hexadecimal, convert this into what? Decimal, convert this into binary, convert this into octal. How to convert this? How to convert this into decimal? So 10 into 16 power 1 plus 11 into 16 power 0. What is the value is? 171. So what is the AB in hexadecimal? What is the equivalent in binary? A means what? 10, right? 10 means 1010. B means 1011 with the base of 2. Then hexadecimal you want to represent in octal, then hexadecimal you represent in what? Binary. Then grouping of what? 3 digits. Sorry, 3 digits. So what is the hexadecimal number is? 253. The base of 8. You don't understand? Can I give some questions on now? Now we understood any number to any number conversion. Correct? Conversion we understood. So now let me give some typical questions to answer. My question is, okay. So this is a very interesting question. So consider addition of the numbers. Okay, I just write it. Consider. The question is, consider the addition of the numbers with the different bases. Consider the addition of the numbers with what? Different bases. With a different basis. Different basis. What is my number is? So x of 7 plus y of 8. Let me write. X of, first question is x of 7 plus y of 8 plus w of 10. W of 10 plus z of 5 plus z of 5. This is equal to what? K of 9. K of 9. K of 9. So what is the value of x is giving? X is equal to 36. If x is equal to 36, y is equal to 67. Y is equal to 67. W is equal to 98. Then K is equal to 241. K is equal to 241. What is asking to do? Find the value of what? Value of Z. Is it Z is equal to 241? K is equal to 241. This value is given. See, in this question, it's not talking about finding the radix. He has given the radix. But he is saying that you find out the what? Z value. You have to find out the what? Z. Z in the what base it is? 5. Means radix of 5. Radix of 5. This question is the number with the different radix. What we are doing is nothing but we are adding it. We are adding. Now we should find out the value of what? Z we need to find out. How to solve this problem? Convert any base into the what? Decimal. So let us convert any base into the decimal. What is x values? 36 with the base of 7 plus what is the y values? 67 with the base of 8 plus what is the value of w is 98 with the base of 10 plus z we need to find out z of y, correct? Z of 5. This is equal to what? 241 with the base of 9. There are different bases. What number system you can see here? This number with what base? This number with what base? Octal. This is a base of decimal. This is a base of 5. This is what base? Base of 9. What are the unique digit of this number is? 0 to 8. What is the unique digit of this base number? 0 to 6. This is what I said, X number system. X number system. How to convert any number to the decimal? Weighted power. How to write the weighted power? 3 into 7 power 1 plus 6 into 7 power 0 plus 6 into 8 power 1 plus 7 into 8 power 0. Correct? Weighted power. Plus 98 with the base of 10 means what? 98 only. Correct? 98. I can write the 9 into 10 power 1 plus what? 8 into 10 power 0. Weighted power. And here, okay. Here how you can represent? How to convert Z of 5 into decimal? Z of 5 how you can represent? Z into 5 power 0. Z into 5 power 0. This is for Z in 5 power 0. Correct. Again, this is equal to what? 2 into 9 square plus 4 into 9 plus 9 power 1 plus. Okay, my screen is not visible, right? Okay, let me share the screen. So now could you able to see the screen? Online students.
Yes, sir.
Okay. Now this is equal to what? 2 into 9 power 9 square, right? Plus 4 into 9 power 1 plus 1 into 9 power 0. So what is the LHS value? 182, right? 182 plus Z is equal to what is the LHS value? 126. I think no. 193. 199, huh? Okay. So 182, this is what I'm getting. 182 plus Z. Correct. This is equal to what? 199. So Z is equal to what? 199 minus 182. What is Z value is? 19. So is a Z in what radix now? Z in what radix? Okay, can you please check it? Z is 17, huh? 17 or 30? 17. Okay, this is 199 is correct? Okay, just clarify this. The LHS value.
Sir, 181.
This is 181, huh? Okay. This is a 181.
180.
180.
180.
180 plus Z is equal to 199. Okay, 199 minus 180. What is the result is? 189 minus 19 is correct. 19 is correct. Is it 19 is in what base? Decimal, right? Is 19. This I can add Z of D. This I can add what? Z of D means decimal. This is in decimal. But what value we need to find out here? Z of 5. The question is Z of 5, not Z of what? Decimal. Then what I need to do? What I need to do? Convert this base 10 into the what? Base 5. How to convert this base 10 into the base 5? This number will be divided by what? 5. This number will be divided by 5. How many times? 3 times. What is the remainder is? 4. What is the value is? 3, 4. Take bottom to top. Now, Z of 5, what is Z of 5 is nothing but what? 34 with the base of what? 5. If you substitute here 34 with the base of 5, LHS should be equivalent to the what? RHS. Are you understood? I think this example will just gives you that number you can represent in what? X number system. X may be 7, X may be 9, X may be 5. Are you understood? Okay. Can I go next question?
Yes, sir.
So let me give another question. Okay, very interesting question. So find the minimal decimal equivalent of the number. I think this we have done. 21A, right? What is that? Okay, equivalent decimal number is talking about. The question is find the decimal. Find the decimal. We find the minimum decimal. Minimum decimal equivalent of the number of the following you can take. The number is 21A of X. Is it correct? Yeah, 21A of X. What is the decimal equivalent of this? How to solve this problem? He's saying that you need to find out the equivalent of this number in what? Decimal. How to find out? And also he's saying that minimal decimal equivalent. Let me see who is going to answer to this question. Okay. But there is no LHS right here. If you have LHS some value, RHS some value, then you can put that into quadratic equation. Then you can find out the roots of that. Then you will get the base X. But just I am giving the number 21A of X, but I have not given LHS value. Only the number 2 1 a of x I have given. Now x value is what? Greater than or equal to 11 or 12 or 13. In that, what is the minimal? 11. So that this, what is the base of this is nothing but 2 1 a of what? 11. How to convert this into decimal? Weighted power. What is weighted power is? 2 into 11 square plus 1 into 11 power 1 plus 10 into 11 power 0. Are you able to follow? So what is the equivalent value of this one is? 269. 263 with the base of what? D. Can you see this option is there? Yeah, 263. The option C is correct. Let me put it. See, to solve this problem, what knowledge you need? How to represent the base. By looking at the number, what base it could be, that you should understand. Correct? So usually these kind of questions they'll ask in the interview. They'll not simply do the conversions, those kind of questions they'll ask. They want to tweak your mind. So to solve this problem, you should know something different, right? Definitely this problem you can able to do only if you have idea about what? X number system. Correct? Or else it is difficult to solve this problem. Let us give another problem. Another problem. Okay, this is also quite interesting. He's saying that the base of the number system, you can note down the base of the number system for which of the following operation? For which of the following operation? Following option is to be correct. The number is 65 divided by 5. This is equal to how much? 13. 66 divided by 5. This is equal to 13. So he has given some options. What are the options are? Okay, A is options are A is 6, B is 7, C is 8. Option A is 6, B is 7, C is 8, D is what? 9. Which option is correct? The base of the number system for which of the following operation is correct? What base is correct for this? Like how to solve this problem? So this question 66 divided by 5 is equal to 13. Sorry, this should be 13. I can simply write like this. I don't know what is the base. That is what I need to find out. I can write like this. Again, this equation I can write 66 base of r 5 what? Base of r. This is equal to what? 13 base of r. So then I can write this equation like this. 66 base of r is equal to 13 into base of r into 5 into base of r. This you can write what? 6r plus what? 6. This is equal to what? R plus 3 into what? 5. Again, this you can write 6r plus 6 is equal to what? 5r plus what? 15. Again, 6r minus 5r is equal to 15 minus 6. Right? Then this is what? R, what is R value is equal to? 9. So that the correct option is what? D. You understood? No. See, what I did is like how to solve this problem is my number is what? 66 divided by 5 is equal to 13. But he's saying that I want to find out the what? Base of the number. This I need to find out what is the base of this number. Right? Base of this number. To solve this problem, so I'm just writing, I need to find out the base, right? So that I can write 66 divided by 5 with the base of what? That is equal to what? 13 with the base of what? So this is whole bar is there. So this base is applicable to 66, also what? 5. So this equation I'm writing 66 with the base of r divided by what? 5 of base of r. This is equal to 13 with the base of r. So now I'm cross multiplying this. 13 into base of r into what? 5 into base of r. So now I'm converting r into the what? R number system into decimal number system. Or converting a R number system into decimal number system is what? 6 into R power of 1. Again 6 into R power 0. R power 0 is nothing but what? 1. So that I can get 6R plus 6 it is. This is a 313 of base R to convert into decimal. This should be what? R plus 3 into 5R means decimal means 5. So then I'm multiplying this so that I'll get R value is equal to 9. So if you substitute R value is 9, are you getting LHS is equal to RHS? LHS is equal to RHS? You can substitute in this equation. R, what is R value? Is 9, right? 6 into 9, how much? 6 into 9? 63 plus 6. 54 plus 6. How much?
60.
Okay, 5 into 9. 45 plus 15. 60. LHS is equal to RHS. What is the right value is nothing but 9. Are you understood? If you get a question like this, how to solve? Can we move on to the next question? Okay, I'll give a very big number. So very big number it is 1560. Note down this question. 156088 divided by 123 of base 10. This number also base 10, this number also base 10. This is equal to what? 710 base R. What is the R you should find out? Can you note down someone? So now tell me what is the value of that number? 1 1560 88. Okay, divided by this is 1 5 divided by 123 power of base of 10. This is equal to what? 710 R. Find the what? Find the R. Base you need to find out. So this equation you can write like this. 156088 with the base of what? 10. Divided by what? 123 with the base of what? 10. This is equal to what? 710 with the base of what? So this you can write 7R square plus what? R. This I can multiply with what? 123. This is equal to what? 156088. So then you can calculate this. 7 into 123. 8. 61. R square plus 123 R minus 156088 is equal to 0. This is in quadratic form equation, right? ax square plus bx plus c is equal to 0. Then you can find out the roots. You can find out the roots. I think this kind of question already we solved, right? So you can find out the correct value of r. What is the value of r? Sorry, understood? I think it takes time to solve because a big number it is. Try to find the correct value of r. Let us go to the next question. Okay, so the next question is, so if 84 of base x, you note on the question, if 84 of base x in the base x number system, in the what? Base x number system is equal to 64 of base y number system is equal to 64 of y. Y is what? Y is nothing but in base y number system. The base y number system. Then what is the possible values of x and y are? Then what is the possible? What is the possible values of what? X and y. What is the possible values of x and y? What is the possible values of x and y? He's saying that this is one, right? 84 with the base of x is equal to 64 of base y. Then we need to find out what is the x value. We need to find out what is the y value. What is x and y? I think he has given the options also. So one is 1219, 6 and 8. A option is 1219. B option is 6 and 8. What is C and D option is? The C and D option is 9 and 12 and 12 and 18. 9 and 12 and 12 and 18. X and y values. Which option is correct? Is it A is correct, B is correct, C is correct, or D is correct? All are correct. Is it all are correct? B, I think no. See, B means X is 6, Y is 8. But you can see if I put X is equal to 6 here, base of 6 it is, but the digit is what? The unique digit is more than the base. But it should not be, the digit should not be what? More than the base value, right? Yes or no? Nine and 12 over 9 or 9 and 12? 9 and 12 is a correct answer. Correct. How it is? Let us solve this problem. How it is? 84 of base x. Correct. What are the possible values of the x? X is greater than or equal to 9. Why? What is the maximum value is what? 8. X could be 9, it may be what? 10, it may be 11, it may be 12, like so on. Some finite value. Minimum value is 9 here. In this case, minimum value is 9. Coming to this number, 64 with the base of y. So y value should be what? Greater than or equal to 7 or 8 or 9 or 10 or 12, like so on. Now, what he is saying that 84 of x, if you choose the x value and y value, if you put x and y value here, this 84 is equivalent to what? 64. What is the value I should select? 84 of 9. This is equal to what? 64 of what y values? 12. This you can write what? 8 into 9 plus 4 is equal to 6 into 12 plus 4. If you convert this into decimal. So 8 into 9, how much? 72 plus 4. 76. Here, what is the value? 6 into 4. 72 plus 4. 76. Now LHS is equal to what? RHS. What is the value of x I should choose? 9. X is 9. Right? X is 9 I should choose. Here, y is 12 I should choose. So that LHS is equal to what? RHS. Yes, Taulak, still some confusion. That is what you need to substitute your y value. This is like iteration. It is an iteration question. Means first you should find out what are the possible values of x and y. In that you should choose what is the x right x value, right y value. So here it is an iteration. Put x9 and x y7. These both are not equal. Then x9 and y8. x9 and y9. x9 and y10. x9 and y12. Some value of x and y, both LHS is equal to what? RHS. See, there are few questions where you have to do iterations. Right? You have to put what is the possible values of the x, you need to substitute to meet the result. Got it? Weighted power? Weighted power means, yeah, you can convert this number into what? One more way is nothing but you can write x square plus 4. This is what you can write x square, x 8x plus 4. Another way is nothing but he is telling very simple way to solve this. 84 of base x is equal to what? 64 of base y. This you can write 8x plus 4, right? This is what? 6y plus 4. You can write 8x minus 6y is equal to what? 0. You understood? If you take 8x is equal to what? 6y. Then you substitute the right value. So this is what? 8 into 9. 6 into what? 12. What is 8 into 9? Huh? 76. 6 into, is it 6 into 12, right? 72. Okay, 8 into 9 is 72, not 76, right? Yeah. This is what? 72 is equal to 72. I think in this equation, but in this equation 6 and 8 is not correct because this base should be what? Yeah, this base should be what? Greater than the 9. First you should find out the possible values of the x. Possible values of the x, possible values of the y. Then you should find out what is the base of this number system. Here 6 and 9 will work fine. But according to this base representation, 6 is not a correct answer. Hello? Yes, hello, online student. Did you understood? Let me give some other typical question. This is all about conversions, as you know. Okay, this one, can you find out? So 1040, again 10401. The question is 1040 10401 with the base of what? 8. This is saying that what? 110110. This is 110110 base of question 1. What base it is? So very big number in octal, right? Very big number in octal. If you see the power of this is nothing but 8 power 0, 8 power 1, 8 power 2, 8 power 3, 8 power 4, 8 power 5, 8 power 6, 8 power 7, and 8 power 8. Very big number it is in terms of octal. He's saying that this number is equivalent to what? This number. Then what is the base in that case? What is the base in that case? Is it base is decimal? Is base is binary? Is a base is hexadecimal? Or any other base it is? Or any other base it is? What is your approach to solve this problem? What is your approach to solve this problem? If number is very big number. So here you need to understand the trick. What is the trick is, if you see any number, very big number, octal in big number, hexadecimal in big number, always try to convert the octal or hexadecimal number into binary. You don't understand? Convert this number into binary. If I convert this number into binary, how I can convert? 1 means what? 0, 0, 1. 4 means what? 0 means what? 0, 0, 0. 4 means 1, 0, 0. Again 0, 0, 0. 1 means 0, 0, 1. 0, 0, 0. 1, 0, 0. 0, 0, 0. 0, 0, 1. This number is in binary, this is equivalent. But this number is not equivalent to what? This number. But I converted a bigger hexadecimal number into what? Binary. Yes or no? Correct? Then what you should do? Now you try this binary to what? Hexadecimal. If I convert this into hexadecimal, correct? Grouping what? 4 digits. Grouping of the 4 digits. Now this is nothing but x 1, correct? This is 1, 0, 1, 1, 0, 1. What is this number in equivalent to this number is? What is the basis? Base is 16. Base is 16. If you see that hexadecimal or binary number is a very big number, try to convert the big number into what? Binary. Then you can group to the hexadecimal, or you want to group to the octal, however, to match the result. Did you understood? So this is a base of 16. Now let us go to the next question. So okay, this is also quite interesting. In an expression, I'll write the question here. Let me write the question in an expression. Expression, what is expression is 11A, 1B with the base of what? 8. This is equivalent to what? 12 CD with the base of 16. Base of 16. A and B. A and B are represented positive digits. Positive digits in octal number system. In octal number system. And C and D are original meaning, right? He's saying that C and D have original meaning. Original meaning in what number system? Hexadecimal number system. What is mean by original meaning is? He's saying that C and D is the original meaning means it should be 13 and 12 and 13. Right? 12, right? B means 12 and 13. But A and B, what he is saying? These should be positive numbers. A and B are the positive number in what number system? Octal number system. So he's saying that find the values. Find the values of what? I need to find the values of A and B. Find the values of A and B. So he's saying that 1, 1, 1, A, 1, B with the base of 8. He's saying that this is equivalent to 1, 2, C, D in the hexadecimal. Where C and D are the original meaning in hexadecimal, but A and B are, he's saying that positive. This number is positive. How to solve this problem? Hexadecimal number to binary. Correct. To binary means 1, 1A, 1B of base 8 is equal to, you convert this hexadecimal into the what? Binary. What is the binary is? 0, 0, 0, 1. 0, 0, 1, 0. C means 12. 12 means 1, 1, 0, 0. D means what? 1, 1, 0, 1 with the base of 2. Base of 2. Now you convert this binary to the what? Octal. If you convert this binary to the octal, group with the what? How many digits? 3 digits. Now this is XX means this is 0. 0, 0, 1 means what? 1. 1. 0, 1, 1 means what? 3. 0, 0, 1 means what? 1. 1, 0, 1 is nothing but what? 5. Now what is A and B positive values? A is equal to 3. B is equal to 5. A is equal to 3. B is equal to 5. Have you understood? So this is mapping to what? 1, right? This is mapping to what? 1. A is mapping to what? This one, 3. This is nothing but 1. And this is nothing but what? 1, 0, 1 is nothing but 5. Now A is equal to 3, B is equal to 5. Did you understood how to solve this problem? Okay. So these are the problems. Even you can take some problems and number system conversions, number representations and number conversions. Are you understood? If I give any sort of question, you'll be able to solve, right? Even in practical session, lab sessions also, we'll give a couple of questions. You can able to do it. Is it conversion is fine? Number systems, representations, solving the problems? Okay. Now let us go to, so why do we need a complements? Why do we need a complements? So before going to this, let us take a break. Take a break for 10 minutes. After the break, we'll start discussing about complements. First, we should understand why complements. Why do we need a complements? Okay. And what complement is better? What complement is generally will be used? We'll understand this. Okay. Before taking a break, are you understanding number systems? If I give some typical questions, could you able to solve it? It may be decimal, it may be binary, it may be hexadecimal, it may be any other number system. Yeah. You can take a break for 10 minutes. We'll restart at 11:50. Then we'll discuss the complements. Okay, let me restart the session. So before break, we were talking about the number systems on types of number systems, correct? Like how to solve the number system questions, correct? Now let us talk about complements of the number systems. Why do we need a complements? The question is, what is mean by complements? Why do we need a complements? What is the use of the complements in the number system? Okay, let us start discussing about complements of the number system. Complements of the number systems. What are the numbers we have? I can simply call X number system. X is equal to 10, decimal, X is equal to 2, binary, X is equal to 8, octal, X is equal to 16, hexadecimal. I can simply call X number system or R number system. R number system. R number system. In any number system, what are its complements are? What are its complements you can call? What are its complements you can call? Suppose it is R number system. What are its complements is nothing but R's complement number system. R's complement number system. And second one is R minus 1's complement of the number system. Let's take base radix is 10. What are its complements are? 10's complement and 9's complement. If radix is 2, 2's complement and 1's complement. If radix is 8, 8's complement and 7's complement. Radix is 16, 16's complement and 15's complement. Now question, if the question is, suppose it is a X, 5 number, radix is 5. What are its complements are? 5 complements and 4's complement. 4's complement and 5's complement. Are you understood? The question is why complements? What is the role of the complements? Anybody? Representation of the what? Negative number. So there is a one way you can represent a negative number using the signed number representation. We'll see there is problem in the signed number actually. There's a problem in signed number. That is not a great compliancy with the arithmetic operations. I'll talk about that a bit later. Okay. So signed numbers are not good for get the degree of supporting of arithmetic operations. So where you can go for 1's complement and 2's complements. So mainly complements are used to represent the what? Negative number. The one use of the complement is nothing but complements are used to represent the what? Negative numbers. See, in your hardware, in your system, you are not putting like a minus sign. System does not understand the minus. Where you want to tell your system, your CPU, that these are representation of this number in negative number. That representation, you can use the word complement. Complements are used to represent the negative number. The another use also there, complements. Using complements, suppose you can perform the subtraction using addition and complements. Okay, so you can perform the what? Subtraction operation. Subtraction operation using what? Using addition and what? Addition and using addition and complements. Let's say what it mean that suppose you have an ordered circuit with you. Order. You want to perform the what? Subtraction. You don't need to exclusively separate circuit or hardware. Using a harder circuit, you can perform the what? Subtraction. So what is the role of this complement here? In this case, here means essentially it will reduce the hardware. Number of gates it will reduce. Using complements and addition, you can perform the subtraction. That hardware, that gates it will going to reduce. This question you keep remember. I'll address what is the use of this, how essentially it is reducing the hardware when I'm talking about the arithmetic circuits, addition, order circuits. The use of this, one more use of the complement is nothing but reducing of the what? Hardware. Reduces the hardware. Reduces the hardware means, now in digital vocabulary, reducing of the hardware means what? You are cutting down of the gates. This is what the mantra of digital designer. What is the mantra of digital designer? As much as possible, right? Reduce the gates. Reduction of the gate, you are indirectly telling that your reduction of transistors. More gates means what? More transistors. So you're reducing the gates means what? You are reducing the switching activities. Right? You're reducing the switching activities. Switching means what? This is what switching you are getting from the what? Transistor. You are reducing the number of switches. Means you are reducing the transistors. This is what mantra of digital designer. So we'll understand now it is reducing the hardware. Hardware means reduction of the gates. How you can perform the subtraction using addition plus complements. This is a second use. So these are the use of the complements. If any number system, what are its complement is nothing but R's complements and R minus 1's complement. Now let us talk about decimal number system. Decimal number system, what are its complements? Decimal number system complements. What are its complements are like? 10's complement. If radix R is equal to 10, base is nothing but 10. Means this is a radix. You don't take this is R is equal to 10. R indicates here radix of the number. So what are its complement? I can write R's complement. R's means what? 10's complement. Second one is 9's complement. This you can call R's complement. 9's complement means what? R minus 1's complement. R minus 1's complement is nothing but 9's complement. If you put R means 10's complement. R is equal to 10 means 10's complement. 10 minus 1 is 9's complement. So how to represent the 10's complement? I said complements are used to what? Representing the negative number. Negative number. Also this is used for subtraction also. Complements are used to represent the subtraction. What is mean by 10's complement means? What is mean by 10's complement? So 10's complements are denoted by R to the power of n minus capital N. R to the power of small n minus what? Capital N. Here, what is the R means what? The radix. What is the N means? Capital N means number. Let's say I'll give one number. This number, what is the 10's complement? How to find out this number 10's complement? This is a decimal number I have given to you. What is the 10's complement of this number? So this is nothing but capital N. Capital N means what? Number. What is a small n means what? Number of digits in the number. Number of digits in the number. Small n means number of digits in a number. In a number. Suppose I want to find out what is the complement of this number. How to find out the complements of this number? How to find out the complement of this number? Let me put like this. How to find out the complement of this number? 10 to the power of 4 minus 1, 2, 3, 4. Correct. What is the 10 to the power of 4 is? 10 followed by how many zeros? 4 zeros. Minus. This is a minus 1, 2, 3, 4. Means what is the 10's complement means? Each digit is subtracted by what? 10. That each digit is subtracted by 10. That is what a tens complement. Means 10 here 0 you can't subtract with 4, so that you are borrowing, right? This is what 10 minus 4 means what? 6. This is what 9. This is what? How much is there? Here it is 9 or 10 is there? 9. Huh? Here it is 10 minus 4 is 6. Here 9 minus 3 is 6.
8 minus 2.
Here it is 7 or 10 it will be.
7.
Is it 7 or 10? So now I can't subtract 0 with the 4, so that we are borrowing, right? When I borrow, this becomes what? 10. What is this value I am talking about? Is it 9 or 10?
10.
Is it 9 or 10 it is?
9.
How it is 9? Okay, tell me. Can you justify how it is 9? So if you borrow here, so if you borrow here, this becomes 10. From here, if you borrow, now this becomes 8, this becomes 9, this becomes 10. So now you are saying that this is 9 minus 3, 6. Okay. This is 9 minus 2. This is nothing but 7, right? Then this is 7. Then 8 minus 1 is here 8 or 9 it is? 9. All these are 9. So 9 minus 1 is what? 8.
8.
So this is what? How to find out the tens complement of the number is nothing but r to the power of n minus n, capital N. What is capital N means what? Number. And small n means what? Number of digits. Number of digits. So if the digits are 4, you can represent 10 to the power of 4 minus a number. That is what the complement of this number. What is the complement of this number is nothing but 8766. How to understood? Then how to represent the nines complement then? How to do nines complement of this number? 1, 2, 3, 4. What is the nines complement of this number is? So I want, I don't want your explain. I want in terms of equations. How to do nines complement? R to the power of n minus 1 means what complement? Nines complement. Correct. What is nines complement? R minus 1 complement. To represent the nines complement, r to the power of n minus 1 of what? Minus capital N. Minus capital N. Means if n is 4, same question. If n is 4, 10 to the power of 4, 10 to the power of 4 minus 1 means what? Means 10 followed by 4 zeros minus 1 means 9999. What is 9's complement? Each digit will be subtracted by what? 9. What is the 10's complement is? 9's complement plus 1 is nothing but what? 10's complement. So this one I can write r to the power of what? 10 to the power of 4 minus 1 of what? Minus capital N. N is 4 means what? 10 to the power of 4 means 1 followed by 4 zeros minus 1. What is minus 1 means what? It is 9999. Yes or no? So this number will be subtracted from what? The number. What is this number is? 9 plus 4 is what? Sorry, 9 minus 4 is 5, 6, 7, 8. This is what a 9's complement. What is 10's complement?
Plus 1.
Plus 1 to the what? Your LSB bit. That gives the what? 9's complement. If you do plus 1 to the 9's complement, that gives the what? 10's complement. Do 9's complement, adding LSB bit to the plus 1, that becomes what? tens complement. But how you can represent the tens complement means r to the power of n minus capital N. Nines complement means r minus 1, r power n minus 1 minus n. Suppose it is an binary number system. Binary number system. You can represent what? Let's say, okay, are you understood this? Do you have any question here? Any question here? No. Can I go to the next? Suppose it is a binary number system. Binary number system complements. Binary number system complements. What are the binary number system complement is? So if the radix is what? 2. 2's complement. Then what? 1's complement. What is the 2's complement means? You can call r's complement, right? This is what r's complement. This is what? R minus 1's complement. R minus 1's complement. How to represent 2's complement? How to do 2's complement? 2 power n minus capital N. Suppose my n value is 0, 1, 1, 0. 0, 1, 1, 0. What is the 2's complement of this number is? N is what? How many digits? 4 digits. What is the 2 power 4 is? 16. 16 means what? 1 followed by 4 zeros. In binary, I am talking about 2 power 4 means 16. 16 in binary is 1, 0, 0, 0, 0. Minus what? Number is what? 0, 1, 1, 0. If you subtract this, 0, now you can't subtract the 0 with the 1. What you should do? Take a borrow. Borrow means what it happens? 2. 2 minus 1 is 1. Next. What is the value of here? 1 or it is 2? Here, what is the value? 1. 1 minus 1 is 0. What is the value here? Is it 0 or 1? 1. 1, right? This is 1. You can see 10 plus 6, how much it is? 16. Are you understood? This is what the 2's complement it is. Now, same problem can you do in the 1's complement? What is 1's complement? The 1's complement means 2 power n minus 1 of minus capital N. Minus capital N. So this how you can write 2 power n means what? Same, you take the same number. This is a base of 2. Base of 2. How many digit it is? Like 4 digit. 2 power 4 means 16. 16 minus 1 is what? 111. Is 1110 or 111 it is? 16 minus 1, how much? 15. 15 in binary means what? 1, 1, 1, 1. I need to subtract what? 0, 1, 1, 0. 1, 0, 0, 1. This is what the 1's complement it is. Correct? This is what the 1's complement it is. Are you understood? If you add plus 1 to this 1's complement, if you add plus 1 to the 1's complement, okay, let me explain one more time, no issues. If I am adding a plus 1 to the what? 1's complement, that becomes 2's complement. Adding 1 to the 1's complement becomes a 2's complement. Usually what you studied is like 1's complement means change. Suppose this is a number, 1's complement means change 1s to zeros, zeros to 1s. This is what you studied. Plus 1 if you add, that becomes what? This is a 1's complement. If you plus 1 if you add, that becomes a 2's complement result. What I'm saying, real expressions. What is a 2's complement is what? 2 power n minus capital N. What is the 1's complement is what? 2 power n minus 1 of minus 1. I'm bringing the mathematical equations here. but you are done the shortcut. Converting ones to zeros, zeros to ones is a ones complement, you said. Adding one to the ones complement becomes two's complement. But these are the real equations, how you can find the two's complement and one's complement. Are you understood? The same thing applicable to octal number, right? Different octal number. Yes or no? Let us represent octal number system. Octal number complements. What are the octal number complements, sir? Octal number system complements. Octal number system complements. Right? You can write what? 8's complement. Then what? Means this is R's complement. R means radix. 8's complement. 7's complement. Means this is R minus 1's complement. R minus 1's complement. So this you can represent 8's complement means what? R to the power of n minus capital N. This is what? R n minus 1 of minus capital N. If R is what here? 8. Let's say this is what my octal number. I want to find out the complement of this number. What I have to do? How many digits it is? 2 digits. Means 8 power 2 minus n. What is 8 power 2 means? 60? 64 minus what? 44. 0, 2. This is what the 8's complement of this number. Are you understood? Then how to perform? Same number, 7's complement. This is nothing but R to the power of n means 8 power 2 minus 1 minus capital N. This is nothing but 64 minus 1 is what? 63 minus 44. What is the values? 19. If you add plus 1 to this, that becomes what? 8's complement. For 7's complement, if you add 1, that becomes what? 8's complement. I feel now, what is your name? Vaidehi Reddy. Now, are you able to follow this? How to do? 2's complements, 1's complement, 10's complement, and then what? 9's complement. Suppose it is hexadecimal number system. 16's complement and 15's complement. Hexadecimal number system complements. Hexadecimal number system complements. What are the complements, sir? 16's complement. Means this is, I can write R's complement. R's complement. Then 15's complement. This you can write R minus 1's complement. R minus 1's complement. Correct? So what is R's complement? How you can write? How to perform? R power small n minus capital N. This is R power n minus 1 of minus capital N. So let us take one number, A, B, C, D. This is what my hexadecimal number. I want to find out the 16th complement of this number. How to do? 16 power 4 minus A, B, C, D. What is 16 power 4? 2? Can you solve? 16 power 4, 65,536 minus AB, CD. Can you do? What subtraction you should do? This is hexadecimal subtraction. Hexadecimal subtraction you should do. What is hexadecimal subtraction for this?
Excuse me, sir.
Yes, hello.
Sir, in previous, we have did the binary number system.
This
You have
one.
taken that you have taken 8's complement and power 2. It's
No, I
Sir,
didn't.
here if we take
Ah.
8 square, so we'll get the result as 64, but it is in decimal, sir, not in octal. So you have to convert the 64 in octal. So we'll get 100.
Correct. I did a small mistake because we have to perform your what? What number system it should be? Octal number system.
Octal.
You are exactly correct. So this 64 you should convert into what? See, 8 square means 64. It is in binary. Sorry, decimal. That you should convert into what? Octal. So what is the octal equivalent of 64? Huh?
100.
100, right? So 64 in decimal, that is equivalent to what? 100 minus 44 we should do. So what is the value? Huh? 56. 56. Yes. So here what you should do, 100 minus 1 is what? 99 here. So 99 minus 44. 55. So here it should not be decimal now, right? It should be an octal. Octal means 64 in octal means 100. 100 minus 1 is what? 99. So 99 minus 44, this should be what? 55. Are you understood? So likewise here also you should do the what? Same thing. So this number, if you put this number, 16 power of 4, so this is what your decimal number. This you should convert into what? Hexadecimal number. Then that number will be subtracted by the number which I have given, ABCD. So then you will get the hexadecimal complement, means 16's complement of this number. Yeah, you can take this as an assignment. Okay. Can you try this? Similar to the what you have done in the octal. Same way, you need a time to solve this. You can take a calculator, you can solve this problem. Now, are you understood how to represent the complements of the number system? What are the complements of the number system? Let's say if it is X number system. It is a X number system. X number system complements are what? What are the X number complements are? X and X minus 1's complement. There is a X complements. Then X minus 1's complement. X minus 1's complement. I can give one question on this. Solve this question. Okay. Take this example. The tens complement. The tens complement. The tens complement of 843 with the base of 11 is. So what number system it is? No, you look at the number. What number system it is?
11 numbers.
11 number system. It is a 11 number system. What are its complements? Are 11 at 10's complement. Correct. So how to solve this problem? What is a 10's complement means?
Minus R power n minus 1.
R power n minus 1 of minus n.
Minus 7.
R in simple way. What is the 10's complement means what? What is the 1's complement, right? 1's complement means converting ones to zeros. Let's say 9's complement means what? Each digit will be subtracted by what? 9. You'll get the 9's complement. To get the 10's complement, plus add 1. So in this question, what I need to do? How to get the 10's complement? Each digit will be subtracted by what? Is it 11's? Each digit will be subtracted by 10 or 11? 10. So each digit, if you subtract by 10, get 10. So you will get the result. What is the result of this? So this is 7. This is 6. This is nothing but 2. What is the base of this is now? 11. Base is nothing but 11. For 11, this is a number of base of 11. What are its complement is 11's complement and what? 10's complement. Correct. How to perform the 10's complement? Each digit will be subtracted by what? 10. Are you understood? And adding plus 1 to this, that becomes 11's complement. What is the answer to this question is nothing but what? 267. 267. The answer is nothing but 267 with the base of what? 11. Are you understood? So next session we'll see that how you can perform subtraction using complements. So why do we need a complements? I said that to represent a negative number. Another example is nothing but do subtraction using addition and complements. So we'll see that how to do the subtraction using addition and complements. When I'm teaching about order circuit, then we'll understand how essentially it will reduce the number of gates, means hardware reductions. Are you understood? Complements. Can you work on few examples on the complements? Okay. So one question I can give. What is the 2's complement of this number? What is the 2's complements of the following numbers? Following numbers. So my number is 2, my number is 4, my number is 8, my number is 16, my number is 32, my number is 64, my number is 128. These numbers, can you find out the 2's complement? You can find the 2's complement of these numbers: 2, 4, 8, 16, 32, 64, and 128. What is the 2's complement of number 2? What is the 2's complement? 2 1's complement, adding 1 to the 1's complement is nothing but 2's complement. 2's complement, what you should do? Represent this number in binary, correct? 2 means you can represent what? 1, 0. Takes the 1's complement. What is the 1's complement is? 0, 1. Add plus 1 to this. This becomes what? 1, 0. Means 2's complement of number 2 is same as what? 2's complement is same, right? 1, 0. If you take a 4, what are the 2's complement of the 4 is? If you take a 4, 4 means what? You can represent 1, 0, 0 in binary. What are it? 2's complement means first you take the what? 1's complement. 0, 1, 1 plus 1. That becomes what? 1, 0, 0, 0. Means 2, 4, 8, 16, 32, 64, 1, 28. Its 2's complement is what? Same. What understood means 2 power. 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6. Its 2's complement will be what? Same. Okay. Tomorrow we will discuss about like what is mean by signed number representation. Why we'll use a signed number representation. Okay. Signed number representation. So positive and negative number you can represent by using sign bit. MSB bit is something like a sign bit to represent whether it is a positive number, whether it is a negative number. Okay. And we'll see that what is the problem with the signed numbers. What is the problem with the signed numbers? So then we will discuss why we will go for complements. Why we will go for complements. Okay. Why you need a 1's complement? Why do you need a 2's complement? Again, we'll see that which complement is good. Whether 1's complement is good or 2's complement is good. Which one is a higher degree of we call higher degree of compliancy with the hardware? Which one is good? 1's complement or 2's complement? So we'll discuss that. Along with that, we'll also discuss, we'll solve some problems using complements. How you can perform subtraction using addition and complements. Are you understood? There are a few cases will be there. Sometimes minuend should be greater than subtrahend. Some case minuend is equivalent to the subtrahend. Some case minuend is less than the subtrahend. There are few cases are there. So we'll discuss the cases when you're solving complements, subtraction using complements. Did you understood? Are you able to follow the number system? Then if I give some questions, could you able to put your knowledge and solve the problems on conversions? Solve the problems on complements? Okay. So we'll continue tomorrow with the complements. Sign bits, 1's, 2's complement, other complements, subtraction using complements. So we'll deal in the next session. Okay. So any questions before stop of today's session? Any question from your side? Can you please go ahead? Are you able to follow? So today there will be practical sessions will be there. Okay. So they will be discussing few more problems on number systems and complements, different questions on number systems and complements. Okay. They'll give the question, but you should apply your knowledge and try to solve it. If you're not able to solve, they'll help you to solve the question. Okay. So with this, I will stop it. Tomorrow you will continue with the complements of number systems. So any question before stop? Okay. So let me stop here. So we'll continue in the next session. And this I think we talked about, right? That you should convert into what? Octal. Octal subtraction if you want to do. Decimal number should be converted into octal. Okay. Okay, let me continue tomorrow.
Thank you, sir.